So the -6 at the back is always my what? My constant, my, yes, carry on. What was it?
Is it y-intercept?
Y-intercept, it's exact constant, and y-intercept was the two things I was looking for. Yeah, you just said didn't do it. That wasn't sad, hey? Trust yourself. -6 is the y-intercept. We agree. I don't know why I'm copying. Press graph. Can you see -6 is your y-intercept? I feel like I'm raising the roof now. Okay. You can see it? So if it's -50 at the back and you're like, I can't see my y-intercept, you got to change your window, right? Your window. You only need to change y's to make your y-intercept show up, right? So you don't need to go viciously changing all of them to 1,000. We agree? Now you might be like, Lepp, you're weird. Why? Because everyone does it. They change everything. It's like, well, I can't see it. I'm going to change it to 1,000. That does not make for good things. Okay, you shift little things so you can still see the graph. Now the graph in front of you should look like a bit of a wonky sideways S-ish shape, correct? How many x-intercepts does it look like it has? Pardon? 3. Looks like it has 3. Now, linear graphs have at most 1 x-intercept and at minimum 1 x-intercept. They will always have 1 x-intercept, correct? Linear graphs will go through an x-axis, whether it's positive or negative slope once. We agree? Then last year we learned about quadratics, okay? Quadratics can have how many x-intercepts? 2 max or 1 or 0. They can have 2 max where it goes nicely through, or if it's concave up and it just touches the x-axis and bounces up, which is called a point of tangency. That would be, it actually has 2 that technically have to be, but they're the exact same one, right? That's the reason why it bounces. There's 2 there, because it hits that x-intercept, and it hits the same one again and bounces it up. So that's why you have 2 there, but technically you have 1. It's just because it's 2 that are the exact same. Or you can have none. The entire bad boy can be above the x-axis, no x-intercepts, because arrows are in the same direction. We agree? So that is with quadratics. Okay? So grade 10 we did linear, grade 11 we did quadratics, grade 12 we do degree 3, 4, and 5. We just like amping things up, you know? When we're like, what? You like 1 and 2, why not 3, 4, 5? That's what I think. So 3 does that little curvy thing, that sideways S. We agree? So this one has 3, but do all of them have 3? We could have something like, nope, don't want that one. We could have something like, I'm going to erase these, don't draw these, don't use this spot, I'm just preempting you. So we could have something like this, we agree? Which has 3. Or we could have something like this. Remember when it was tangent, it actually made us have 1, it just happens to have 2 at the same spot. So with a quadratic, that's what I was saying, like it hits here and hits 1 and then it bounces it back up because there's actually 2 here. They just happen to be the exact same. So with a degree 3, it could do the same thing. It can pass through and then it can hit this one and bounce up. And what would that mean? There's 1 here, there's actually 2 here, they just happen to be the exact same. So how could that look? It could be like x plus 3 and then x minus 3 squared, right? That squared would get you the 2 there, right? Yep.
So if we had that graph and were asked how many x-intercepts there were, would we say 3 or 2?
So you'll use multiplicities this year. So you'll say x equals -3, and then you'll say x equals 3 multiplicity 2, saying that there's actually 2 there.
Okay.
So use the word multiplicity and then however many are there behind the x-intercept. Now to say if there's 1, 2, or 3, or 4.
Okay, that comes a little later.
Yeah. Then you could have just 1, because it could do this, and there would be 1. But at minimum, a degree 3 is still going to have 1, because it's going to cross through at some point because the arrows are in opposite directions, just like a linear, right? You're going to have a minimum 1, but you could have 2, you could have 3. The key thing about polynomials is if it's an odd function, you'll always have, odd functions mean degree 1, degree 3, degree 5. You'll always have at minimum 1 x-intercept and maximum the degree. So this is a degree 3 function, it's going to have a maximum 3, and then anything in between, so 1, 2, 3. Okay, so degree 5 is an odd function, so it's going to have at minimum 1, maximum 5, but it could have 2, 3, 4 in between as well. Degree 2, which we talked about, can have 0, 1, or 2. Degree 4 can have 0, 1, 2, 3, or 4. So you max out at the degree, you minimum out depending on if it's even or odd. If it's even, you minimum out at 0 because the arrows are in the same direction, so it could be completely above or completely below. And if it's odd, you minimum out at 1 because the arrows are in opposite directions. It's disk going, it's going to have to cross through at least once. Does that make sense? So those things are good to know when you're starting to do synthetic division. Now, I don't have an eraser, and I have to do this. So when we look at this one, we know synthetic division wise, we need to make a large L, and we know that we need to rocket count. And if we can't rocket count, we put a 0 in it as a placeholder, correct? So we go to check our rocket counting. We go 3, 2, 1, and then technically x to the 0. So we can rocket count this. So we can put the numbers in. We agree? We can put in all the coefficients. So we can put in a 1, a 2, a -5, a -6. We agree? Yesterday I said it was divided by x plus 2 or x minus 2 or whatever, and we put the actual root in front of it, correct? This time I didn't actually tell you. I just told you to factor it. So the numbers that you would put in here to see if you get an x-intercept of 0 are actually the factors of 6. So it's always the constant at the back. So it'd be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now that would take quite a while. You'd have to plug in 1, see if you get a 0 in the remainder box. Plug in -1, see if you get a 0 in the remainder box. Plug in 2, plug in -2 until you get a 0 in the remainder box. Right? That would take some time. Hopefully it would be 1 or -1. But really what we're looking for are x-intercepts, are we not? Is our calculator getting pulled away from us? Am I ripping it out of your hands at any point in time in this class? No, AT I will. But in here I won't. In calculus you have parts that are calculating, parts that are not. So I'm not taking it away from you. So you can look for an x-intercept, correct? So what you can do is you can go second graph, because it's into your calculator already. Go second graph. Now remember, on your table of values, only the integer x-intercepts are going to show up, correct? The decimal x-intercepts won't show up. So you might have 3. If one of them is 1.5, it's not showing up on that table. We agree? So if you go second graph, look and see what is the smallest or most negative x-intercept. What are we getting? -3. So I'm going to try that one. You could do any other ones. I'm going to go x equals -3 so that we know it's an x-intercept. And then I'm going to write x plus 3 above it because that's actually the factor. Remember, we work our way back to get the factor. So we have x equals -3. And now we can try it out. We have to get a 0 in the box at the bottom. It has to be a remainder. Now, if I pulled the calculator out of your hands, you put in 1, you'd put in -1, and you'll see if any of them work to get you a 0, right? You just sequentially do that. And if it ever said, what are possible roots, you would say any of these numbers could be possible ones. Now, some people will say, like it's on a test, they'll say, well, none of them are possible. I plugged them in, and none of them got me 0. Possible just means they could be possible. Possible doesn't mean they actually are. So anything that is a factor of your back number is possible. You either get you a 0 or not. So watch yourself if it's a multiple choice that says possible, or if it says is a factor, or is an x-intercept. That's totally different. Okay, so our first step is to draw an arrow, bring down the 1, and then after that I'm going to multiply and add until I'm done. Remember, multiply, add, multiply, add, multiply, add, multiply, add. So I'm going to go -3 times 1, bring it up, is -3. I'm done multiplying, so I'm going to add. I'm showing the arrows for this one, and then after that I won't show arrows anymore. 2 plus -3 is -1. And then I'm going to multiply. -3 times -1 is 3. And then I'm going to add. -5 plus 3 is -2. And then I'm going to multiply. -3 times -2 is 6. And then I'm going to add. -6 plus 6 is 0. And now I should be really happy because that's an actual remainder of 0, which means I picked the right number. Now, I always pick the smallest number just so that when you guys go to work on it on your own, we're all following the same number. It just makes it a little easier because you could have picked any of the other two and it'll still work out, but our next step won't be the same, right? Because we'll have different numbers at the bottom. So this was an x cubed. I took an x out. What are these going to be? X squared. So now I have 1x squared, and then I go down in order. Minus 1x minus 2. And then what do I have to do with that? Factor it. So it says factor, correct? So in the end, I need factors. Factors are those things in the brackets, like x plus 3, x minus 2, x minus 5, 5x plus 1 in brackets. Not the x-intercepts, the factors, right? X-intercepts are x equals. The ones in brackets are factors. As long as you know that, this is easier. Some people give me factors when I ask to solve and solve when I ask to factor. So I need to factor this. And if I can't factor it, I would be done. It would just stay in this bracket. If it says factor and you can't factor, you're done. But I can factor it. I say what times what gives me the outside numbers, -2. And what plus what gives me the inside, -1. And what do I get? -2 and +1. And then I can say, well, because there's a 1 in front, I can go right to brackets, correct? I don't have to decomp. So I'm going to go x minus 2, x plus 1. And then people box this and say that's the answer. What do I still need? X plus 3. There's a factor up here. So actually, when I get this factor, I will immediately write it down in the answer so that I don't forget it. Because it's really easy to just forget it, right? To forget to write it again at the end. Then I box it. This is factored. So if I want to check if I'm right, type that into Y2. This should be the factored form of the original. Should give me the same graph. It's just a different way of looking at the graph. So in your Y2, you should be typing that. X plus 3, bless you. X minus 2, X plus 1. And remember I told you if you have not the fancy ones with the different colors, you can go over to that slash line and hit enter and make it thicker. Because what happens sometimes is people think it's the same graph and really the one graph being drawn and the other one is off to the side, like outside the screen, and you're like, awesome, it's the same graph, but it's not. So you make it thicker slash, you'll see it actually draw on top of it. Then you walk away from this question going like, I'm a rock star, I got this, right? And if you forget the x plus 3, you'll put this in and it won't match, and then you'll be like, why doesn't it match? Okay? All right, we're going to flip to the next page. So, we're going to go down to B here for a second. What are my possible x-intercepts? Yeah.
Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10.
So if I didn't have my calculator, I would put in 1, I put in -1, I put in 2, I put in -2, 3, -3, and see when I get a remainder of 0, right, on my synthetic division. But I do have a calculator, so I want you to type this into your calculator. I don't know what is going on. Which is the lowest one you got? 5? Don't do this. Stop madness. Don't follow along. Like, you just let me do this next step. Okay? Don't do this. It's wrong. So I'm going to go 1. I'm going to go -27, and I'm going to go 10. I'm going to drop the 1. I'm going to put a 5. I'm going to add it. I'm going to get -22, and I'm seeing bad things happening because that ain't going to subtract and give me a 0. So then I go, oh no, I picked the wrong number off my calculator. And I go back to my calculator and I feverishly try and find the right number, when in reality, what did I just forget to do? Yeah.
You put 0 as a placeholder for the x squared.
Because we always do checks with your rocket count. And if you forget to rocket count, you'll do this and you'll be like, wait a second, I know I picked the right number. I picked a 5. 5 works, but why is it not working? And it's because you're missing that placeholder. So we are missing, we have 3, 1, 0. So we're missing a 0x squared. So we need to put that in as a placeholder. So we have 1, we have 0, we have negative 27, we have 10. We know x equals 5. We know that's a solution. We know that's an x-intercept of root or a 0. We know the factor is x minus 5. We put x minus 5 down here in the corner because I want to remember it so I don't forget it. And then I see if I can do some work. So I drop the 1. 5 times 1 is 5. Add it. 0 plus 5 is 5. Multiply. 5 times 5 is 25. Add it. Negative 27 plus 25 is negative 2. Multiply. Negative 5 times negative 2. And now I'm getting happy because I can see that I'm getting an x-intercept of, or sorry, a remainder of 0. Now that was an x cubed. So this is going to be an x squared. 1x squared plus 5x minus 2. Now the reason why Chloe couldn't find a lower one or anything better is because this bad boy here can't factor, right? And if I can't factor and I ask you to solve, okay, let's say it's solving, which is going to come after this lesson. If I ask you to solve, you actually have to type that into the quadratic formula and get me an answer if I say solve. But if I say factor and you can't factor, you just have, this is called a trinomial factor. You can't factor it. You just go over here. This is like when you should be happy. You have no more work to do. You literally go over here and you write it. So sometimes they'll ask you, what is the linear factor? Which one of these is linear? Which one's linear?
X minus 5.
X minus 5. And the other one is a quadratic factor, or a degree 2 factor, or a trinomial factor. So they can use those words and ask you for the other factor too, right? They could say when this factors down, the binomial factor is ax squared plus bx minus c, the values of a, b, c respectively are. They can do that as well, right? Okay, look at C and D. Aren't they pretty? Try them out.